All right, guys, this is the video for Keeping It Fresh Chapter 3. So number 1, 2, 3, and 4 says determine which operation each word represents. So difference, that's always a tricky one because it starts with D and students sometimes think it's division, but difference is subtraction. Products means we should be doing multiplication. Sum is addition, and quotient is division. Number 5 is an order of operations problem from section 1.3. So remember, order of operations, please excuse my dear Aunt Sally. So parentheses, exponents, multiplying and dividing from left to right, and adding and subtracting from left to right. So if we look here, I have parentheses, so I want to do that first. Remember, I've noticed some of you on your last Keeping It Fresh aren't rewriting all the parts of the problem that you're not doing in that step. You need to rewrite it all, because otherwise you're going to get lost with your steps. Remember, our work should be going vertically, pizza slice work. We shouldn't be writing equals here and then have the rest of the problem. That's confusing. So I rewrote my 15, my minus, and my 4. Inside the parentheses, I'm supposed to add. So 6 plus 1 is 7. Now this 4 is right next to the parentheses. Well, remember, that means multiplication when a number is right next to parentheses. So I could either keep the parentheses and just write that answer of 7 inside, and hopefully I would remember that means to multiply, or I could use a multiplication symbol once I figure out that it's a 7. So I could write 4 times 7, and then I still need that division sign and then 2 to the second power. So I've done parentheses. Next would be exponents. 2 to the second power means 2 times itself twice. So 2 times 2 is 4, and see how I rewrote everything else. Now I've got subtraction, multiplying, and division. So multiplying and division come first. It's whatever's first from left to right. So in this case, that's multiplying. So 15 minus 28 divided by 4. Now I want to do dividing. 28 divided by 4 is 7, and then 15 minus 7 is 8. So that's our answer for number 5. Number 6 is also order of operations. So I have parentheses, which I want to start with, but inside the parentheses, there's actually more than one operation. So I have to think through order of operations all over again and decide what happens first. Do I do that exponent first, or do I subtract first? So that would be exponents that comes first. I'm going to keep the parentheses since I know there's still things inside there to do. 5 to the second power, remember, means 5 times itself twice. So 5 times 5 is 25, not 10. And then I still have minus 4, close the parentheses, times 2, minus 18. Now I can do the subtraction inside the parentheses. So 25 minus 4 is 21. And then I have the times 2 minus 18. 21 times 2 is 42. And then I want to do 42 minus 18. I'm going to line that up vertically here. I can't do 2 minus 8, so I'll need to borrow from the 4. 12 minus 8 is 4, and 3 minus 1 is 2. So our answer there is 24. Number 7 and 8 are find the prime factorization of 54 and the prime factorization of 72. Remember, prime factorization means do the prime tree. A mistake people made on the chapter 2 KIF is a lot of people just told me, oh, 54 is composite and 72 is composite. Well, yes. Any number we ask you to do the prime factorization of would be composite because we want you to tell us what prime numbers multiply together to equal 54. So to figure that out, you're going to do a prime tree. So 54, remember, you break it up, get your branches. You think of any factor pair you can think of that multiplies to equal 54. So there's more than one right way to do this. Now I'm going to pick 6 and 9, but 2 and 27 would work. There are other factor pairs that would work besides just 6 and 9. So now I ask myself, is 6 prime? It's not, so I'm going to break that up as well, more branches. Is 9 prime? No, it's not, it's composite, so it needs branches as well. So now I do the same thing with 6 that I did with 54. What's 2 numbers I can think of that multiply to 6? Well, 2 and 3 would work. And what's 2 numbers that multiply to 9? 3 and 3 would work. Is 2 prime? Yes, so I'm going to circle it. Is 3 prime? Yes, so I'm going to circle all those 3's. Now my answer I'm going to write using exponents. So I'm going to have 2 times, not a comma, not just a space. These are being multiplied together, so a times sign. And then I have 1, 2, 3 3's, so I can write that as 3 to the third power. 8, same thing, just different number. So 72, a lot of factors, pairs you can come up with for 72. I'm going to use 8 and 9. 8 is not prime, and neither is 9, so I need to break those up further. For 8, I could use a factor pair of 4 and 2. For 9, I could use a factor pair of 3 and 3. 4 is not prime, so that needs more branches. 2 is prime, and 3 is prime. 4, I can use a factor pair of 2 and 2 is prime, so I can circle both of those. So if I look, I have 1, 2, 3 2s, so I want 2 to the third power times, I have 1, 2, 3s, so 3 to the second power. Number 9, find the GCF of 72 and 84. A lot of students needed help with this back on the Chapter 2, Keeping It Fresh. These are going to pop up on a lot of your Keeping It Freshes, so you need to make sure that you are keeping on top of that and reviewing it and asking for help if you need it. We in class, the main method we used for finding GCF was the KIF method, which is not in your book. So you either need to make sure you hang on to your notes from this section, or you hang on to these Keeping It Freshes with the correct work so that you can remember how to do this, because this will pop up again on more KIFs. So find the GCF of 72 and 84. So we take those two numbers, we write them, and then we put our first layer of cake around those numbers. Then what you need to do is come up with any number you can think of that divides into 72 and 84. Now those numbers are a little big. Maybe you don't know a number off the top of your head that goes into both. Well, then use your divisibility rules. Look at the end of these numbers, 2 and 4. They're even. So I know even numbers I can divide by 2, so that's always a good place to start. Yes, I might have more layers of cake, but if I can't otherwise think of a number to go into it, that's always a good one to start with. So 2 goes into 72 36 times. 2 goes into 84 42 times. Now these numbers are getting a little smaller, maybe a little easier for us to recognize a factor that goes into both. Well, maybe you look at those again and you're still not real sure. Well, they're still both even, so I could still use another 2. Now, just like prime trees, KIF method could have different ways of looking. Maybe you didn't pick 2 to begin with. That's okay. Our answer should match up at the end. 2 goes into 36 18 times. 2 goes into 42 21 times. There is a number that divides into both of these. Obviously not 2 because this is odd. So if you know 2 doesn't work, you should start working your way up through the divisibility rules. Okay, does 3 work? Remember 3, the rule is if the numbers add up to a number divisible by 3, it's divisible by 3. So 1 plus 8 is 9, I can divide 9 by 3. 2 plus 1 is 3, I can divide 3 by 3. So these are both divisible by 3. 3 goes into 18 6 times, 3 goes into 21 7 times. There is no number that divides into 6 and 7, so I know that's when I stop. My GCF is all the numbers on the side here multiplied together, which is why you'll still get the same answer even if you use different factors to begin with, because no matter what, your number should also multiply to the same answer. So we're going to do 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. So our GCF of 72 and 84 is 12. Now you might have realized it was 12 right off the bat. You might have recognized these as your 12 facts. That's okay. Then you would have just had a 12 here, and then your 6 and 7 at the bottom. Find the LCM of 36 and 60, section 1.6. Again, you can use the KIF method, but that's not in your book. We set this up very similarly to what we just did for GCF. You write the 2 numbers, or 3 numbers if you're given 3. You put your layer of cake, and you think of a number that divides into both. So a number I can think of would be 6. 6 goes into 36 6 times. 6 goes into 60 10 times. Those numbers are even, so I know I could at least still do by 2. 2 goes into 6 3 times. 2 goes into 10 5 times. There is no number that divides into 3 and 5, so I know that was my last layer of cake. Now GCF is the numbers on the side. LCM is the numbers on the side and the numbers on your very last layer of cake. Remember, we talked about in class that this basically forms the letter L, and that's how you can remember that. So we want to do 6 times 2 times 3 times 5. So I might do 2 times 5 because I know that's 10, and 6 times 3 because I know that's 18, and then that makes my multiplication a little easier here. 10 times 18 gives me 180. So 180 is your least common multiple. All right, number 11, in an aquarium, 2/5 of the fish are surgeon fish. Of those surgeon fish, 3/4 are yellow tanks. What fraction of all the fish are yellow tangs? So we're in chapter 2 now, fraction word problem. The trick here is figuring out what operation am I supposed to be doing. Well, it says 2/5 of the fish are surgeon fish. Of those surgeon fish, 3/5 are yellow tangs. What fraction of all the fish are yellow tangs? I see a lot of ofs. Those ofs, remember, can mean multiplication. They also could just be a common word in the English language, but in this case, it's telling us that we need to multiply these two numbers together. So 2/5 times 3/4. Remember, you can cross reduce. There's no number that divides into 3 and 5, but I could cross reduce 2 and 4. 2 divided by 2 is 1. 4 divided by 2 is 2. So 1 times 3 is 3. 5 times 2 is 10. I need a label. It said what fraction of all the fish are yellow tangs. 3/10 are yellow tangs. Number 12, you have 3/5 of an apple pie. You divide the remaining pie into 5 equal slices. What fraction of the original pie is each slice? Well, that's a pretty obvious key word there, divide. Now, just because they told us what operation to do doesn't mean it's still an easy problem, because remember with division, order matters. I have to put these numbers in the correct order or I won't get the correct answer. So I now need to decide, is it 3/5 divided by 5, or is it 5 divided by 3/5? And remember, it isn't always that the biggest number is first. I know that that was kind of the case in elementary, but it's not anymore. So it says I have 3/5 of an apple pie. I divide the remaining 5 into 5 equal slices. So I'm dividing into 5. So that means that 3/5 needs to get broken up 5 equal ways. So I need to divide 3/5 by 5. That's the order it should go in. Remember the 5 I'm going to write over 1. Now remember division, you do skip times flip, keep it, switch it, flip it, keep, change, flip, whatever your catchy little saying is to remember. So I need to change this problem to 3/5. That part stays the same. Division becomes multiplying. And 5 over 1 becomes 1 over 5. There's no cross reducing I can do, so I'm just going to multiply straight across. 3 times 1 is 3. 5 times 5 is 25. What's our label? It says what fraction of the original pie is each slice? It's 3/25 of the pie, of the original pie, but just of the pie is fine. Number 13, you buy 2 7/5 pounds of tomatoes. The tomatoes cost $1.89 per pound. How much do you pay for the tomatoes? Remember, another trick you guys can use if you're not sure what operation to do is pretend like these are whole numbers. So 275, that's close to 3, so let's pretend for a minute that's 3. 189 per pound, that's close to 2, so let's pretend it's $2 per pound. So if it was I buy 3 pounds of tomatoes and each pound costs $2, how much do I pay? Well, I would think to myself, okay, 3 pounds, each is 2. So I need 2 for the first pound, 2 for the second pound, 2 for the third pound. So I'm doing 2 times 3. So I need to multiply here, but I gotta use the real numbers, not these fake ones that I used to figure it out. So now that I know it's a multiplying problem, I know I need to do 2 7/5 times 1 89. Well, remember the key with multiplying is I don't need to line up decimals. I'm just going to pretend like they're not there, and I'll worry about them at the end for my answer. So I'm going to just think of this as 275 times 189. So my first line of work here is going to be that. Then I'll need to start with a 0. And then I'll start with 2 zeros, and when I do my multiplying times 1 there, I'm going to get 5, 7, and 2. I'm going to run into my other problem here just for a minute so we can see the answer. When I add down, I get this, 51975. Now that's not my answer. It doesn't cost $51,975 for those tomatoes. That would be crazy. I need to now go back and look at my original numbers and count how many numbers were behind the decimal. There were 1, 2, 3, 4 numbers that were behind the decimal. So starting from where the decimal is right now, which would be here, I need to go 1, 2, 3, 4. So that gives me 5.1975. Remember, what's our label? How much do you pay? Okay, well, paying would be in dollars. But I can't pay $5 and 1,975 10,000ths of a cent. So remember, we need to round here. Money goes to the hundredths place. So the money should stop there. Now that doesn't mean I just stop at 9. That means I got to look at the 7 here. and decide what happens to that 9. Well, 7 means this should round up. Well, 1 more than 9 is 10. So that means this place is going to become a 0, and then I carry that 1 for the 10 over here. 1 plus 1 is 2. So it rounds up to 520. Think about it like this. If you were to cover up that 75, I'm going to cover it up. Oh, that didn't work. Oh, it didn't work either. Well, let's pretend that's not there. Maybe I'll just color it out with pen. Ooh, it's gone for a minute. 519, it needed to go up 1. Up 1 from 19 is 20. So $5.20, that's our answer. All right, number 14. Let me get rid of some of this work here. It says you have 3.4 gigabytes of memory available on your iPhone. Each song is about 0.04 of a gigabyte of memory. How many more songs can you download on your phone? So, I have 3.4. Each song's 0.04 of a gigabyte. I want to know how many of these I can fit in there. That's a division problem. So I want to divide 3.4 by 0.04. So remember, if I write it this way, that's not actually how it's going to look when I set it up in long division. This is my dividend. So 3 4/10 goes underneath the division sign. 0.04 goes out here as the divisor. Now I need to have a whole number out here when I divide decimals, so I need to move this over 1, 2, 3 times. So I need to move this over 1, 2, 3 times. Well, that means I need to fill in these empty egg cartons, or as Mr. Moe would call it, butt cheeks, with zeros. And then I need to move that decimal up into my quotient. I'm going to rewrite this to get rid of all the egg cartons / butt cheeks. So it's really now like I'm just doing 4 into 3,400. And I know my decimal's there and there. So 4 can't go into 3, but it can go into 34. Oops, not 9 times. 8 times. 4 times 8 is 32. Subtract 2 and bring down your 0. 4 goes into 25 times. We're not done because there's still another 0 in my answer before I hit the decimal, so I need to bring down that 0. And then I need to say, how many times can 4 go into 0? It can go in 0 times. Now I can stop because I have run out of numbers in my dividend, so I can say 850. So 850, and my label would be songs. All right, evaluate the expressions when A equals 10, B equals 9, and C equals 4. So remember, evaluate means find the value. It's not called solving because there is no equal sign here. I'm just taking those values for the variables, putting them into the expression, and then using the math to get the value. So 2A, remember, means 2 times A. So when I put in this 10 for A, I don't just want to write this, because now that looks like 210, and that's not actually what I'm supposed to be doing. I'm supposed to be doing 2 times A. So I should write that 2, and then write a little time sign, and then put in my value for A, and then rewrite the plus and the 3. Now I need to follow order of operations. So I want to multiply first and then add. So my answer here is 23. 16, I have A plus 9C. So I'm going to put in 10 for A, rewrite the plus sign, rewrite the 9. 9C means 9 times C, so I'm going to write my times sign. And then C is 4. 9 times 4 is 36. And 10 plus 36 is 46. Here I've got b to the second power plus 5. So b to the is 9, and then I need that exponent of 2, and then plus 5. I want to do exponents first. So remember, 9 squared means 9 times itself twice, so that'd be 81. 81 plus 5 is 86. 18, what property does this example represent? I see 2 plus the quantity 3 plus 4 equals the quantity 2 plus 3 plus 4. I'm going to check to see if the numbers are in the same spot from left to right. They are. The order of the numbers didn't change, so that means it's not commutative, because commutative means I can change the order of my addends. What did change is the grouping. Here I grouped 3 and 4 together, here I grouped 2 and 3 together. So remember, the associative property is the one that says it's okay to change grouping in an adding or multiplication problem. And I need to specify it's the associative property of addition, because it's addition that's happening in the problem here. 19, what property does this example represent? W plus 0 equals W. So I'm showing that I'm adding 0 to a variable and getting that variable back as my answer. So it's an addition property. I see addition. It's the addition property of 0, which states that if I add 0 to anything, I get that same answer back. And then last, simplify, 9, and then in parentheses 2x plus 1. This is the distributive property. That's what 3.4 was all about. The distributive property tells us that if I can't do what's inside the parentheses, I can actually take this number next to the parentheses, because remember, a number next to parentheses means multiplication, and I can multiply first. I just need to make sure that I distribute, that I multiply that 9 to every term that's in those parentheses. So basically, I need to do 9 times 2x and 9 times 1, which I showed with my little arrows here. 9 times 2x, remember, I can multiply those two numbers together, so 9 times 2 is 18, and then I'll just have the x next to it. 9 times 1 is 9. I cannot add these together because this has an x and this doesn't, so they're not what we call like terms. So it's just going to stay 18x plus 9. And that's our Keeping It Fresh for Chapter 3.